In this video, we want to talk about the derivatives of general logarithmic and exponential functions. And in order to do this, we really need to use the change of base formula for logarithms. So just as a quick reminder, if you have log base b of x, we had the change of base formula, which basically said take natural log of x and then divide by the natural log of b. And I just wanted to remind you that this natural log of b, that's a constant because b itself is a constant. Okay? So what we want to do is we want to apply this formula with a general base b and the base e corresponding to the natural logarithm in order to calculate the derivative. So let's differentiate the general log with base b of x, and we're going to apply the change of base formula that we just reviewed here. And remember, because this natural log of b is a constant, we could use the constant multiple rule. Which means we could factor the 1 over ln b out of the derivative. And taking the derivative natural log of x is going to give us 1 over natural log of b, which is a constant, times the derivative of natural log of x, which is just 1 over x. So we can piece this together to get the following formula. The derivative of a general logarithm is written like this, and that's equal to 1 over x times the natural log of b. And we can put a box around this. We could shade this guy in. This is one of the basic derivatives that you should probably memorize. Okay, let's move on. Let's talk about the derivative of an exponential function with base b. So let me tell you the formula first before we go ahead and prove it. The derivative of a general base b to the x power is just going to be b to the x times natural log of b. So let's highlight this. This is something that we should all memorize. In addition to the derivative of the general logarithm, you want to memorize the derivative of the general exponential function. All right, let's take a look at the proof next. To do this proof, we have to remember the cancellation property. Now, the cancellation property said that if you took e to the natural log of really anything, you're going to get the same thing back because e and natural log are inverse functions of each other. So in particular, if I were to put e to the natural log of b, I would just get b back. Okay, so let's remember that as we go through our proof. So we wanted to take the derivative of b to the x power. And what I'm going to do is I'm going to rewrite that as the derivative of e to the natural log of b to the x power, like this. Okay. And remember, we had that the third law of exponents, which says that when you have a power to a power, you multiply the exponents together. So this is just going to be the same as the derivative of e to the natural log of b times x, like this. Okay. And we could really, this thing, we're going to need to use the chain rule. The outside function is the exponential e to the something. And as we know, the derivative of e to the something is just going to be e to the something. So we're going to write natural log of b times x like this. But according to the chain rule, after taking the derivative of the outside function, we need to multiply by the derivative of the inside function. So let's write down the differentiation operator, and then let's get the inside function. ln of b, remember that's a constant, times x. Okay. And what does that equal to? Well, we know that this piece right here, that was just our b to the x. So we write our b to the x. And we got to multiply that by the derivative of a constant times x. So the derivative of any constant times x is just a constant, and that constant is natural log of b. So we write natural log of b here. Okay. So this basically gives us the formula that we're looking for. We can see that the derivative of b to the x is just b to the x times natural log of b. We can do the same thing in reverse. In other words, if you know that the derivative of b to the x is b to the x times natural log of b, then this means that the antiderivative of b to the x should be b to the x divided by natural log of b plus some constant. So this is yet another antiderivative that we should memorize. So let's highlight that guy. Okay. All right, everybody. This is the basics of the derivative and antiderivative of a general logarithm and exponential. Take care, everybody.